Hello once again, class, and welcome to another mock lecture. Today, we're going to discuss experiments. Now, one thing that's oftentimes confused with an experiment is called an observational study, which is a study that's based on observations or measurements only. And this can be things like the number of people wearing red, for example, or it can be about solicited responses in a particular survey, like what do we notice about them. Whereas an experiment is a study in which the effects of an outside influence are measured. Right? The outside influence is referred to as the treatment that is applied to the subjects of the particular study. So, a real-world example of an experiment. Let's say that a pharmaceutical company tests a new medicine for treating Alzheimer's disease by administering the drug to 50 elderly patients with recent diagnoses. The treatment here is the new medicine. Here's another one. Let's say that a gym tests out a new fitness program by enlisting 30 volunteers to try the new program. Here, the treatment is just the new program. So, let's see if we can spot the differences between an observational study and an experiment. What I want us to do is determine if each of the following is an experiment or an observational study. So the first one says the weights of 125 randomly selected people are measured. Well, there's no outside influence that's taking place in this thing. This is simply just an observation of 125 randomly selected people's weights. So this is an observational study. How about this one? Subjects are asked to do 20 jumping jacks and then their heart rates are measured. Well, this does seem to have an outside influence. The 20 jumping jacks are going to influence the person's heart rate, so this is most likely an experiment. 20 coffee drinkers and 20 tea drinkers are asked to take a concentration test. Here, again, the outside influence seems to be that you're drinking something and then being tested on your concentration levels afterwards. Here, maybe you're comparing coffee to tea, but in either case, this is also most likely an experiment. Now let's go back to that first example of an experiment that we saw. A pharmaceutical company tests a new medicine for treating Alzheimer's disease by administering the drug to 50 elderly patients with a recent diagnosis. How are we going to figure out if the drug has results or not, that it's successful, that it works? Well, oftentimes what's done in studies is you break the participants up into two groups. One that's going to get the treatment and the other that's going to get what we call a control. So the definition of a control group says this. When using a control group, participants are divided into two groups, a control group and a treatment group. The treatment group receives the treatment that's being tested while the control group does not receive the treatment. This is done to test effectiveness or lack thereof of the treatment itself. Now, whenever you make the decision to break participants up into two groups, like a control group and a treatment group, then there's some things that you have to consider when you're doing that. First, the effectiveness of the treatment is going to be influenced by the patient's perception of how effective the treatment might be, which can actually cause a result to be seen even if the treatment is ineffectual. And many of us may know this as the placebo effect. It's like that one time in Harry Potter and the Half-Blood Prince when Ron Weasley became keeper of the Quidditch team and Harry pretended to add a small amount of the liquid luck or the Felix Felicis to his drink at breakfast so that Ron would feel more confident about his abilities, and then he just went on to play a nearly perfect game. And then afterwards he was like, oh, actually that wasn't the Felix Felicis at all, you just played that well all by yourself. That's like the placebo effect. And if you have no idea what I'm talking about, then this reference is completely lost on you, but you should read the Harry Potter novels. To counteract this effect, a placebo, or a dummy treatment, is typically given to the control group, and this allows us to see if the result shows up in both groups to determine if the treatment is really effective or not. Like, for example, if we're only seeing the result show up in the placebo group and not the treatment group, then we can conclude that the treatment is actually not effective at all. It's just the people's belief that it's supposed to do something in the placebo group that is influencing or showing us the result that we're seeing. And this situation describes what is called a placebo-controlled experiment. It's a controlled experiment in that you're breaking up your participants into two groups, a control group and a treatment group, but also a placebo is being given to that control group. The second thing to consider, wouldn't the patient's knowledge of what group they're in set up preconceived notions of the effectiveness or lack thereof of the treatment? Like if they know they're in the placebo group, they might not have any placebo effect take place. Or if they know that they're in the treatment group, then maybe they're the ones that are going to see placebo effect. And then how do we know if the results that we're seeing are because of the placebo effect or because of the actual drug itself? Well, typically, you don't tell them what group they're in, and this is called a blind study. It's a study in which the participant does not know whether or not they are receiving the treatment or the placebo. And then you might ask, well, what about the people interacting with the participants? If they know which group a participant is in, could that not inadvertently influence their evaluation of that participant? Like, could they treat them differently if they know they're in the placebo group unconsciously? Or could they treat them differently if they're not in the placebo group, if they're in the treatment group? And again, all of this could be unconscious. Yeah, this could also happen, but we can make it so that the people that are interacting with the participants also don't know, and that is called a double-blind study. It's a study in which neither the participant nor the people interacting with the participant know who is in the treatment group and who is in the control group. So let's look at some examples and determine if what we're looking at is a controlled experiment, and then whether or not the study is blind, double-blind, or neither. So in a study about the effectiveness of an antidepressant medicine, participants are randomized into two groups, one that takes the medicine and another that takes a sugar pill. The people evaluating the participants are asked to observe behavior over weekly visits and do not know which group the participants are in. So the two questions are, one, is this a controlled experiment? And two, is it blind, double-blind, or neither? Well, the answer to number one is certainly yes. In fact, we know that it's not only is it controlled, it's placebo-controlled. And we know that because the second group gets a sugar pill. In the medicinal field where you're taking pills to test a drug, maybe a drug is given in pill form, a sugar pill is often used for the placebo group, for the control group, as it were. The second question says, is it blind, double-blind, or neither? Well, we don't tell the patients at all in this study what group they're in, and also it even explicitly says that the people that are interacting with them don't know which group the participants are in. So I would say this is a double-blind study. Okay, what about this one? To test a new lie detector, two groups of subjects are given a test. One group is asked to answer all the questions truthfully, and the other is asked to lie on a set of questions. The person that's administering the test does not know what group each subject is in. We have the same two questions. Is this a controlled experiment, and is it blind, double-blind, or neither? Well, for number one, I said that it is. The control group is the one that's asked to answer all the questions truthfully, right? That's the control group. I would not say that it's placebo-controlled like the other one because, they're not taking anything other than the test itself, but you can't give a fake test like with a lie detector stuff. It's just a test, and it's going to be the same for both groups. The difference here is that one group is telling the truth and one group is lying. So it is controlled, but it's not placebo-controlled. The second question is a little bit tricky because it's asking, is it blind, double-blind, or neither? I would argue that it's actually not blind because I would say that the participants will know which group they're in. They're either telling the truth, they're even told, right? You're telling the truth, or no, I want you to lie on some of this stuff. So they could discern which group that they're in. But it does explicitly say that the person administering the test doesn't know which group each subject is in. So it's like the administrator is blind, but the participant is not. Well, we don't have a definition for either of those things, so I would say it's not blind, and it's therefore also not double-blind. So I said that this one was neither. So that's it for this one. Just a quick one about experiments. Hopefully you guys learned something. If you have any questions, please leave a comment below or shoot me an email. Thanks a ton for watching, and I'll see you in the next one.